In 1945, American engineer Percy Spencer noticed that whenever he stood next to a World War II radar transmitter, the chocolate bar in his pocket would melt. That discovery led to the invention of the microwave oven. This may sound surprising, but some of the greatest discoveries came from repurposing previous technology. But did you know that you can also repurpose drugs for cancer? Recently, it was noted that patients who were prescribed dopamine-related drugs for diseases such as schizophrenia or Parkinson's disease were less likely to develop cancer. This sparked the idea, can we repurpose these drugs for cancer? In my PhD research, I'm testing whether we can repurpose these dopamine-related drugs for ovarian cancer. When I tested these drugs on cancer cells in a dish, I found that some of these drugs stopped cancer cells from growing and even killed them. However, the human tumor is much more complicated than cells in a dish. It is a complex 3D structure made of layers and layers of different types of cells, and this structure can change how the drug is absorbed and how the drug is delivered to cancer cells. Therefore, to test how effective dopamine-related drugs are in a more complex representative system, I am making a 3D drug testing model. This is essentially a mini tumor in the lab made from very thin slices of patient biopsy. Another issue is that the drugs I'm testing are unprotected. When you administer drugs to a patient, that drug has a long journey before it reaches the tumor site. It must pass through the digestive system, the bloodstream, and then penetrate layers and layers of cells. Therefore, sometimes the drug can get broken down too early, even before it's reached the tumor. Similarly, when the drug is traveling through the bloodstream, it can bind to proteins in the blood, causing it to be deactivated. To solve this, I am developing tiny drug packaging called nanoparticles. They coat and protect the drug from being degraded and deactivated too early. Another challenge is that drug can get lost within the human body and can accidentally target healthy cells and not the cancer cells. Therefore, to solve this, I am attaching special proteins to the outside of the drug packaging that will specifically locate and target the cancer cells. The end goal is to deliver the majority of the drug to the cancer site for maximal effect. This will allow us to fully understand whether dopamine-related drugs can be repurposed for ovarian cancer. So just like the microwave, maybe there's a brilliant invention already out there, but in this case, just sitting on the pharmacy shelf, just waiting to be repurposed for cancer. All it might need is a little tweak and exploration to realize its full potential.